We're a bi-weekly blog TV show and podcast focused on issues of atheism, science, skepticism, rationality and anything else. I'm your host, Technoman for the evening, Zulu Fight Runner, and joining me today are my co-hosts Kitch.
Hey guys.
Mortimer.
Hi everyone.
Big Lundy.
Greetings everybody.
Okay, now we do take live calls via Skype, so just add the Skype contact, Trolling with Logic, all one word, and just send a few messages just giving us the general gist of what your call is all about. Do not call us, we will call you back. And also remember to mute your blog TV when you're on air. If you can't get through on Skype today, feel free to ask questions in the chat room or send a PM to a chat room mod. And if you can't get through, you don't want to ask a question today, and any questions or criticisms of the show, feel free to email us, trollywithlogic.com. And as a quick reminder, all the calls, the whole show is uploaded to YouTube and iTunes for later viewing. So if you're not comfortable with that, then please don't call in. So I'll hand over without further ado to introduce our special guest, Big Lundy.
On the day of January 29th, 1935, millions upon millions upon millions of particles had coagulated over the course of 9 months due to biological processes to form the baby that would grow up to be one of the most outspoken critics within the field of physics for religion. Writer of many books about God and what he feels science has to say on the matter, including God, the Failed Hypothesis, God and the Folly of Faith, and his newest book for 2013, God and the Atom, ladies and gentlemen, particle physicist and professor of philosophy, Dr. Victor Stenger.
Well, hello. What a pleasure to be here.
It's a pleasure to have you on, Dr. Stenger. So, I suppose we should probably just get straight into the questions. The first question is one that I actually had while I was watching the pre-show, because we had a lot of clips of you with another interview, I think it was on the Atheist Experience with Don Baker, and you said that you felt that morality itself is about human behavior, which is an observable phenomena, and as such, science can comment on it. My question is, to what extent do you mean by that?
Well, I'm not sure why there should be a question there, because it is an observable phenomena that we're talking about here, human behavior, and my only point of raising that is that science does have a role. When Stephen Gould produced his no overlapping magisterium model for the separation between science and religion, he basically tried to redefine religion as moral philosophy, and said science should essentially stay out of moral questions. Well, that's one of the points that I dispute over that. I think science and religion overlap. They both talk about morality. They both talk about the cosmos and everything else. And so they're not separate. And this is an area in particular where science does have a role to play.
Right. The only reason I brought that question up was because I agree that science has a role in explaining morality and helping us determine morals and all that kind of stuff. There have been books released recently by, well, for Sam Harris it wasn't recent, but he produced The Moral Landscape, where he explained how he felt science could play a role in morality. And I think Patricia Churchland recently set out a book as well explaining how the mind works and what the mind is referencing when it's believing in morality, when it's talking about morality. So I think to that extent, and as far as being able to describe all the effects of actions, science has a significant role in informing our morality. So I would agree with that. I think the only reason I actually posed the question was because I was wondering if you thought that it was just science alone that could determine morality.
Well, it's part of human activity. Every human activity that bears on the question has a place in the picture. Science is fine, and Sam Harris in particular makes it very clear that he's not saying that morality should be defined by science. It's just that science has something to contribute. I think here we're not making any strong statement except to point out that that science, as well as history, which is a kind of form of science, has a lot to say about how how morality developed. In particular, there's a huge literature out there that has developed over the last few years about the evolution of morality as a social phenomenon, even possibly as a physical phenomenon, because many animals produce, show kind of, you might call it pre-moral behavior. They take care of each other. They sacrifice for each other. And there's been a lot written about that, even going back to Richard Dawkins' Selfish Gene. And I believe Darwin also wrote about morality from an evolutionary standpoint. So it's an interesting issue, and it's a big issue, and it's one that there's a lot of literature on it. So to just close out science from even considering that is ridiculous, because it's just not going to happen. Scientists are going to study anything that they think they have a role to play.
Mm-hmm, mm-hmm. Apparently, we have a caller who wants to call in and talk about, what was it again? Amit Goswam, a physicist that claims that science has discovered God. So kind of like the polar opposite of you. Zulu, if you would cue him up.
Okay, he's ready. I'll just add him in. And it's kind of name well known to us all, regular caller Sub-Zero Bob. Hello, Bobby.
Bob,
Yes,
can you hear us?
yes.
Okay, ask
Awesome.
your question.
Hi, Dr. Stenger.
Hello?
Hi, how are you? Not hearing you very well. It's just far out.
Okay, I'll try to speak louder.
Okay. Are you familiar with the Professor Amit Goswami from Oregon State University?
Oh yes, I've met him. I even heard him speak at one time, and I was invited to give. It was at the philosophy department in Hawaii. He gave a talk, and I was invited to respond to it. I'm very familiar with his work. I mentioned it in my third book called The Unconscious Quantum, which came out back in 1995. So I'm very familiar with his arguments.
Okay. Actually, I'm not familiar with your book, and should pardon my ignorance. I haven't read what you said about him, so if you don't mind, can you, I guess, tell me or tell everybody what you say against, or how do you interpret what Dr. Amit Goswami says when he is talking about being a quantum activist or discovering God with science?
Yes, he's not the only one out there. There's a whole movement out there called, which I call the quantum mysticism, which basically says that quantum mechanics provides us with the basis to believe that human consciousness can act on the physical world. And Goswami is not the only one. Deepak Chopra is a proponent of that, of course. And there was a series of books that came out not too long ago. One of them, The Secret, was a bestseller. And the argument in all these cases is based on something that goes back to the early days of quantum mechanics, which is called the wave-particle duality. And the wave-particle duality basically says that something is either a particle or a wave. Physical object can be either a particle or a wave, depending on what you decide to measure. So if you decide to measure a particle-like property, such as position, then you're making that object a particle. If you are trying to measure a wave-like property, such as wavelength, then you are basically making that object a wave. And so your mind, in other words, is controlling reality. And this could be not only in the present, if the objects come from some distant galaxy, 13 billion years in the past, which means it's 13 billion light years away, your mind can essentially decide the reality of something throughout the universe, throughout all time and throughout all space. This is basically what this argument is saying, and it's the source of the notion that we're all to a cosmic consciousness. So it's a very deep idea, and it's very popular, and there's a whole wide range of people studying this, but they are on the fringes. So you have to understand these people are on the fringes within the physics community as a whole. The working physicist, you won't find too much support for the idea. And it's basically flawed for a very simple reason, and that is that it's not that an object is either a particle or a wave. It's always a particle. When you do a double-slit interference experiment, for example, you always measure particles. And a wave-like property that people talk about is not associated with any individual particle, but is associated with the ensemble of particles. It's just the statistical distribution of particles, and that's what quantum mechanics does for you. It doesn't tell you how an individual particle will behave, it tells you how the ensemble will behave. In any case, consciousness has nothing to do with it. You can't change reality by just thinking about it. This is what these people claim. Deepak Chopra said that many times. We make our own reality. We can decide what we want to be. We can be beautiful, handsome, we can be intelligent, and we could be healthy. All we have to think. And look, the proof is in the pudding. The proof is in what you observe. Deepak Chopra started writing this about 30 years ago, and he's aged just as much as I have. So I think that's the way you have to always look at any question. This is not theoretical. That's what one think philosophically, but what do you have to actually observe in nature? And you don't observe these claims at all. They're totally inconsistent with anything we know, either theory or experiment.
Okay, well, the sound at my side started to break up at the end, and I couldn't make out most of the things for the past 40 seconds. I don't know if that's something to do with the Skype. I don't know if Zulu can fix it.
Well, right now we're pretty much working on the connection that we're getting after Zulu rebooted his router, so I think it's about as good as it's going to get for now.
Yep.
Okay. Well,
You talk
maybe.
And so, I suggest you go to my website, which you can find by just Googling my name, and you'll see a number of not too long articles on quantum spirituality, and maybe that'll answer the question for you.
Well, I wanted to, when you started talking about philosophy, maybe Big Lundy can step in and say what's the role of philosophy in science, and why is it such a bad thing to talk about philosophy and science, or just trying to combine both of the, they could be opposite of each other, or they could work together, but I think when they work together is when it gets better.
Well, they certainly do work together. The thing is, different philosophers have different bias when they're interpreting science. What philosophy is supposed to do when it's employed correctly is to just help us understand what the scientific evidence and what the science is saying. Philosophy is not to move forward and make new theories about what the science is there for. That's what science is supposed to be doing. All of the philosophy is supposed to do is to help us formulate what the science is saying within our own minds, without confusion. The problem is that plenty of philosophers, like the likes of, say, William Lane Craig, or Deepak Chopra even, and I hesitate to call him a philosopher, but what they do is they speculate way more than the scientific evidence allows them to, and that's not something that a philosopher is supposed to do.
Well, when I watched Neil deGrasse Tyson video, Science and Faith, he clearly states that faith is not against science, but what you guys are doing, what your whole proposition is that science is against faith. Even what I'm looking at Block TV, it says that science goes to the moon, but faith flies you into buildings. So that is a statement that science is against faith. Whereas faith is not.
No, it's To be clear, it's not a statement that science is against faith necessarily, but more that faith doesn't drive you anywhere the way that science does. They're both trying to address the same question, and science does it way better. That's the point.
Ooh, and with
but
philosophy, we bring meaning into.
Can we let Dr. Stenger speak?
Yeah.
Yes, yeah. The last book of mine is called God and the Folly of Faith. And I take a stronger stand than our moderator just pointed out. I think science should be acting against faith because faith is foolish. Why should you believe in anything if you don't have any basis for it, any evidence for it? That's the whole point of science. Science is based on evidence and argument and rationality. And that's the point. That's why I use that expression. Science, religion. Science flies us to the moon. Religion flies us into buildings. That's a good example of the difference between science and faith, and why faith shouldn't just be allowed to proceed. It should be challenged. It should be questioned.
It's like saying what's more important, is imagination or knowledge more important? And without imagination, you wouldn't get any leap in science or any advancement whatsoever. You need imagination to make that extra leap, and that's where believing in faith comes in.
Can I step in here?
Go for it.
Sorry, I shouted "big" there for some reason. Utter brain fart. Sorry about that, Dr. Stenger. But what I'd really seriously contend that imagination and faith are completely and utterly are not really one and the same. Imagination is idea making and just trying to come up with new ideas, great ideas to explain phenomenon, or come up with stories like Lord of the Rings or something like that, depending on what you're using it for. I would argue that it's not the same as faith. As I don't believe in Lord of the Rings, but I can come up with that and come up with that story, or I could come up with a great theory or hypothesis, more to be more correct. But I don't believe it until I test it. That is not faith. And hopefully someone could put that a bit more.
From my perspective, it has to do with context. I mean, imagination is fantastic if you're going to be writing a fiction book, or if you're going to be just essentially entertaining people. That's a fantastic thing to have. And it's also a good thing to have when forming hypotheses. Sorry, Dr.
Okay.
Yeah, I was going to say that, don't forget, imagination comes in the formulation of scientific hypotheses, too. It's very much a part of the scientific method.
Absolutely.
Exactly. But you don't believe
you don't believe a hypothesis until you test it and you provide evidence for that hypothesis. That's the thing. That's the difference. It's the state in which you assign belief to things is different from imagining anything to be true and actually accepting it as true. It's that belief factor. That's the difference.
But again, that's taking a negative stand towards or against faith and against, just making baseless assertions. And in a lot of...
I think it would be pretty good to take a stand against baseless assertions.
I don't think so, because a lot of hypotheses in history that have been proven wrong are just as many that have proven right through the basis of imagination or assertion or the basic principle behind the mechanism of science.
Can I step in here?
Hold on, Marty.
Sure, Martin, you can put a better time on it.
Okay. Well, with your position on faith, how about you have to give me $1 billion right now, or you are going to be hung up upside down from your testicles. Do you believe me?
This is the type of aggressive statements that I'm going after. We all have. If I told you that God is Darth Vader, would you think that that's ridiculous? If you think that it's ridiculous, then you know that there's
I
a
would
difference
certainly
between
not
God
have
and
faith
Darth
in
Vader.
that idea.
I would say
You
that if you
certainly
were
not have faith in Darth Vader, but you know that it's different, and you know that it's funny to compare both because you know that they're not the same thing.
What does that have to do with faith?
here's the thing,
same
Bob.
the same example that you're using right
you
now.
don't-
You know
and
it's
you,
ridiculous.
You don't have
Where
faith
if I-
in what I said, but you just said that faith. Well, you seem to be implying that faith is a good thing, so you should believe me.
Not
despite
all
having no
faith is a
evidence.
good thing. It's not all faith. It's a certain amount of faith that is good, and not completely 100%.
Then the question is, how do you determine that? By what metric do you measure that some faith is, that this kind of faith is good and that kind of faith is bad?
You
have
could
to be able
use
to separate.
philosophy. You could use logic. You could use philosophy. You could use just the natural order of things that are present in the universe, and that brings from that order. We have rationale and we have reason.
Which
So
tells
you
us
could-
that faith is a bad thing.
For
Yeah,
you, but not for me, because for me, when people are proposing the Higgs field and starting to build the biggest shrines, scientific shrines to
That's
talk
not
to God,
faith.
that is faith, because there was
No.
no evidence that there was a Higgs boson rather than just proposing there is a Higgs field.
There was a
And
hypothesis.
that kind of
Bob,
thing has been done in
Okay,
history
Bob,
before.
Bob. Hold on. We've been over this before, you and I, where you bring up the Higgs field and you say, hey, they believe that on faith, and then they continued to go forward. They didn't none of them believed that prior to evidence. There's a reason why Higgs was fairly ostracized from the scientific community until evidence for his proposition was put forward. Because nobody believed it. They investigated it, they tried to see if it was true, but they didn't believe it prior to any evidence being put forth for that proposition. That's the thing.
Can I clarify that
Sure, you probably know more than I do about that subject anyway, so.
Peter Higgs has always been, since he first wrote his papers, has always been a very respected member of the community. And remember, he wasn't the only one. There were 5 other authors who proposed back in 1964 the existence of the Higgs boson. And everybody got very excited about it. The theorists got all excited about it because it really did help explain a lot of problems, and it turned out to play a key role in the development of the Standard Model in the 1970s. Without the Higgs boson in that model, you wouldn't have had this successful model that was successful for 30 years. In fact, it's still successful. There still hasn't been a single experiment to disprove the standard model of particles and forces. What happened this year was they finally found evidence for what looked very much like the particle that had been predicted by Higgs and the other 5 authors. They were three independent papers, incidentally. And that's the way science works. I mean, it was part of the theory. It was always understood. I mean, they spent $10 billion building this Large Hadron Collider, whose primary purpose was to find the Higgs boson, or if not to find it, find out why it didn't exist. It was a key to the whole scientific development of the Standard Model.
That's my mistake then. I think I was probably taken in by the theater of the media and how they played this whole thing. I mean, you have people saying that Peter Higgs, he didn't have a lot of money at the time, and he was out of work, and they finally had this evidence, and he was so happy about all that kind of stuff. It was probably the theater that drew me into that conclusion. So that's my mistake. I apologize for that. But the thing that you mentioned, Dr. Stenger, was you said that when the equations that were proposed by Peter Higgs and the others were put to the test, they worked, and they worked very well, and they were instituted into the Standard Model. They helped to create the Standard Model, and that would be an instance of showing that there is evidence to believe this thing to be true. So again, They didn't believe it on faith. They had to test it first, and then they believed it.
And you notice the other thing about the way it was tested, you had two independent experiments. And this has been a characteristic of particle physics over the last 30 years. When they have searched out these new phenomena, they have not believed a single experiment. They've always insisted that there be independent experiments searching for the same phenomenon, but using different techniques, different people. Both of them had about 3,000 scientists. Both of the experiments cost about $1 billion each. But that's what it takes. I mean, today, to move science forward takes a lot more effort than people sometimes think. And when I hear talks about quantum consciousness and so on, and the paltry evidence that it has, and the paltry effort that's being put into it, and compare it with something like just happened with the Higgs boson, I have to laugh at the absurdity of it.
Okay, can I finish up with one thing, Dr. Stenger?
Sure.
I have a direct question towards your beliefs. Would like to know if you believe that life can exist or does exist on exoplanets.
It seems to me very hard to believe that life would only form here on Earth. Now, I think that the fraction of planets that are out there that are suitable for life is very small. You'd be lucky if it's 1% of the planets that are out there that have even any kind of chance of producing the complex arrangement of quarks and electrons that we call life. However, to then think that human life could live on another planet, that will ever be able to move to another planet and live the way they do on Star Trek, for example, to just sit down on a planet and be able to breathe the air, that's never going to happen. That's maybe our robots will settle other planets, but are destined to stay here on the Earth and live it out.
So would you say that my view is wrong to say that this is the creation story, that the formation of particles that lead to the formation of planets, stars, galaxies, the universe, all of that is leading to not only the formation of a planet, but the formation of RNA, DNA, and formation of life? Isn't that a deterministic creation view of life, of existence?
No, why does that follow? I mean, we already found from evolution how the great role that randomness plays in the development of life. Now, it's true we don't have a theory yet for the origin of life on this planet, but there are many plausible scenarios, and I have no doubt that someday a physical means will be demonstrated for producing life. And this
but
couldn't happen.
If life happens...
Not likely. Look, the chances of any human type of life evolve, even on our planet, you start the whole thing up again in life, humans would have evolved. No species that now exists or ever existed would have evolved. Every one of them was a result of accidents, mutations, and then natural selection.
So this type of accident can happen on planet Earth as well as on exoplanets, and that is not...
So as long as we know it didn't happen on any other planets in the solar system. At most, there might be some simplified life that exists someplace. We'll still be able to find it under the surface of Mars or deep down in one of the lakes on some of these moons. There might be some other form of life. It will be wonderful to find such a thing. But life is pretty easy to make on Earth. I mean, look at these deep sea, these life forms that exist in the deep sea vents. Very different from the life on the surface of the Earth. And yet, if you examine them, you bring them to the surface and you look at them, they have the same DNA we have. Same DNA. All the life on Earth has the same DNA. And that's the amazing thing that evolution has taught us that is really quite remarkable.
So, Dr.
Okay.
Stenger,
Well, hold on, Bob. We're gonna have to move on. You've been calling for a little while now. Well, you said last question a few questions ago.
It's related. I want to know about what
Okay.
his vision is for evolution and for the humankind evolving into different species in the future. What are we becoming? Are we, if we're looking at the context of no direction, just random accidents, and looking at it, thy will be done, making all possibilities possible. What is your view on becoming, on the next stage of evolution for humanity?
When you look at the Galapagos Islands, why are there all these different species on the Galapagos Islands? Because of the separation. New species evolve in isolated environments. The humans do not live in an isolated environment except the Earth itself. We're all over the planet. There's no real pressures of the same type that lead to species development. The next species that more advanced species than us is going to be made out of silicon and computer chips and so on, and not flesh and blood.
So it's pretty much going to be a transhumanist progression, if it's going to be a progression at all.
Yeah.
Okay, Bob. That was the last question. That was the last question, and Dr. Stenger responded. So we're going to have to let you go now. Sorry, but you've been calling for a little while. So
I didn't talk. I spoke maybe 5% of the time. So I didn't take up any of your time. I had all my questions asked.
5% accurate.
I appreciate it, and I thank Dr. Stenger, but I'm still not convinced in your ridiculing, faith and all that stuff.
Well, that's fine.
All right. Thanks for the call, Bob.
Have a good one, Bob.
Thanks for calling, Bob.
Yes, thank you to Bob for calling. By the way, as a reminder, that will be uploaded onto YouTube for anybody who might have missed any bit of that. And we'll move on to more questions until we have more callers. Does anybody else have a question before I move on?
Maybe I have a few, but I think I'll probably wait until the proper topic comes up.
Okay, I was going to ask you about your Monkey God program, Dr. Stenger. Can you explain what that's all about?
Well, it's actually a pretty trivial program that I first wrote back around 1990. I had read this paper where they had shown that the basic physical parameters of the universe, like sizes of planets and so on, can be calculated from a few simple formulas involving just 4 fundamental constants. And so I wrote a program where I varied those constants and just to see what kind of universe would develop. These are all toy universes, surely, because obviously it takes a lot more parameters to create a universe. But the main thing that I was interested in was a lifetime of stars, because in order for life to exist, at least the kind of life we talk about that's created by, that's made out of, I shouldn't say created, that's generated by the natural processes of complex chemical elements, carbon and oxygen and so on. And that carbon and oxygen is produced in stars. And furthermore, for it to evolve on a planet of a star, the stars have to have a pretty long lifetime to allow life to evolve. And so I was looking to see what the variation, one of the formulas gave the lifetime of a star as a function of things like the mass of the proton, mass of the electron, and the electric charge, the value of the electric charge. Those were the 3 main ones. And it was interesting. I found out that varying these parameters by 10 orders of magnitude over their actual values, I still found that more than half of the universes generated had stars with lifetimes of 10. Well, that the message I drew from that is that, despite what people say, the kind of universe that you need for life is probably not that unusual. And in my book that came out a couple of years ago, last year I think actually, called "The Fallacy of Fine-Tuning," was an elaboration of that, not just monkey God, but all kinds of other arguments to show that it wasn't that surprising that some form of life would form on a lot of planets. Now, that didn't mean that our form of life was that natural form of life would probably not exist, as I said, on any other planet in the universe. Our form of life is so very tightly tuned to the parameters of the Earth. Just that there are other forms of life one can conceive of, because life is a very simple thing in my life. Is just lots of particles that interact with one another and reaching a level of complexity of the interaction. You have a rock, is that a rock? The same particles, nothing different. A biological organism doesn't have any different particles or any different forces involved. There's no special life force that anybody has ever been able to come up with. Special biologic features. People things. There's no evidence. What happens? Well, eventually develops something very complex that has to be so.
Hello, Dr. Stenger.
Yeah, I'm getting problems listening to him.
Yes, I think we've lost it. Can you hear us, Dr. Stenger?
I hear you fine.
All right.
Oh, all right.
Okay, it seemed to cut up quite badly there towards the end, but you seem to be fine now.
Also, I've been requested to make this announcement to wish a happy birthday to Niels Bohr, the father of quantum mechanics, as it is his birthday today, October 7th. Born 1885. Yes, 1885.
Okay, and
while you're offering congratulations, you might send some to my wife and I. We had our 50th wedding anniversary just yesterday.
Oh, congratulations on that.
Congratulations.
And also a happy birthday to one of our absent co-hosts, Empty Without Brain. He is 23 today, I believe.
Oh, to be 23.
To be young again. There's another question that was asked by one of the chatterers. Have you ever met Richard Feynman?
Oh, yes, several times.
He always struck me as an extremely interesting.
I even give talks where he's in the front row asking questions. It's always terrified me, but he treated me very gentlemanly.
Whenever I see videos of him doing interviews, he always seemed like an extremely interesting individual to me. And he had some very controversial things to say about the state of science. I think he referred to the social sciences as pseudoscience, and some forms of medicine, not just homeopathy or alternative medicine, but some forms of medicinal research as kind of pseudoscience, in the sense that he said, well, you know, with my work, I know how hard it is to find knowledge, and I don't see these guys going through the rigorous things that are required to get knowledge. They don't come up with laws. They don't come up with these things, and to me, it just doesn't seem like science. If it's anything, if it's anything like what they express. Do you mirror those sentiments at all?
Well, I've been a major critic of medical science and psychological science journals in the low standards that they have for publication. And that spilled over into the pseudoscience of parapsychology. It's definitely a pseudoscience, where the parapsychologists will publish a paper and they'll say, well, look, it's just as significant as this medical journal article over here about something. And there have been a number of studies of the publications in medical journals, and there was even one said that none of them are right. I mean, I would say half of them are wrong. The results. Now, there's a reason for that, of course. I mean, they don't often. A medical researcher doesn't have time to repeat experiments with a lot of patients and so on. And there's always the rush. There's always the pressure to publish because you might have something that'll save lives and so on. I can appreciate that. But the standard for the longest time, I think it's getting better, was confidence, published with a confidence level of 5%. And that means that 1 out of 20 publications will have the same effect. If you did the same experiment, I'm saying, 20 times, you would see this effect once as a statistical fluctuation. And it sort of implies that every 20 experiments are wrong. And that was a criteria that was applied. And by comparison, this Higgs boson discovery, the chances that it was a statistical fluctuation, I forget the exact number, but it was 1 in 3 million or something like that, in 2 independent experiments. Now, the difference between that and what you see in these other fields is the sort of thing that I think kind of off, that they shouldn't be making such strong claims. Maybe they can tone down their claims, but a lot of money is spent and a lot of cures that are worthless, and they should be able to do a better job than that if they want to call themselves scientists.
I think a lot of people would agree. In fact, one person who agreed, who would agree with those sentiments, actually sent me a question when I asked if he had anything, because he's interested in physics. He asked me what your thoughts were concerning the many worlds hypothesis. The interpretation, sorry.
Yeah, well, first of all, the original paper by Everett was a wonderful paper. He was able to develop for the first time, I think, a formalism of quantum mechanics that included the apparatus in the system. And that was always the big bugaboo with the previous quantum mechanics, where that was mainly due to Bohr, where you treated the system quantum mechanically, but then you treated the instrument that was making the measurement classically. So that was a huge improvement. Now then, people went from there and started giving it a philosophical interpretation, which seemed to imply that there were many different worlds, and that every time you made a measurement, the universe split up into all these worlds. I never liked that idea very much. Furthermore, there have been a lot of alternatives to that particular model. In my book, Timeless Reality, I showed how you could use the same ideas if you take into account the fact that time is reversible. There's nothing in physics that requires a particular direction of time. Every equation in physics, classical or quantum mechanical, works in either time direction. And our only notion of a narrow time is based on the fact that we are composed of many, many particles and that are moving around mostly randomly, and certain things happen in one direction and they have a much higher probability than the other direction. I'm talking about time again, like the air in a room, for example. If you open the door, there's some probability that all the air in the room will escape. All that has to happen is the molecule pointing out the door. So that's possible. So time is in principle reversible, and we only don't observe that because there are certain things that happen on the macroscopic scale that are far more happen. But in any case, once you accept the fact that time is reversible at the quantum level, at least where you have just few particles, paradoxes disappear, and you really don't need the many worlds hypothesis. You can have the same things happening in a...
Hello, Dr. Stenger. Are you still there?
Yeah, sure.
Oh, sorry. Oh, sound like we lost you.
Every once in a while, you cut in and out.
Yeah. I think.
Well, I'm not changing my position with respect to the...
Yeah, I think it just must be a connection issue. Kitch, I think you were going to butt in there, like with scientific journals and all that, that we're going into your territory now.
Scientific journals. Yes, I know my own little... I know I do research in... starting out research in the biomedical applications of biogenic nanoparticles, which probably, I think half the audience have just gone, just done a double take, just wondering what the hell I'm talking about, but that's not important. But I agree with Dr. Stenger that some of these journals do come out and they are quite quite strong when they come about their medical, when they're reporting their results. And I would say they would have to. From my own experience, I would say that they'd have to do that in order to get published, because it's quite competitive. If to get into a high journal, if you want to get published, you really want to have something groundbreaking. That's more of a criticism of the system, but that's something you should be aware of when you're reading journals. Is to go more with the data and not what the authors are hyping it up.
This was pointed out to me. This is a pretty interesting fact. Dr. Stenger, you started your PhD in physics around the same time that the very popular show Doctor Who started. Was there any sort of connection there between Doctor Who and your interest in science, or?
I never even knew about Doctor Who. Maybe
okay.
It existed in the UK. I don't remember it on but I didn't watch much television anyway. Still don't.
So just an interesting coincidence. Nothing.
So did you know that Richard Dawkins' wife was on Doctor Who? She was an actress on Doctor Who. Did you know that?
Yes, Lala Ward, isn't it?
Yes.
She was one of the Doctor's companions, if I remember right.
Very nice lady.
Moving on to other questions that I've been given to you. I already asked you about that article earlier. We can skip that. I've been asked to just kind of get your general thoughts on a few topics in physics. Namely, what's your position concerning... Could you explain what you think about dark matter, dark energy, what it is, if it's actually there, if it's purely theoretical, all that kind of stuff?
Sure. The evidence is overwhelming that there is both this dark matter and what's called the dark energy. Although they're both material in nature, the dark matter, interestingly enough, there's a new interesting field starting to expand now. For the longest time, the favorite candidate for the dark matter were the so-called WIMPs, weakly interacting massive particles, which are supersymmetric particles. And frankly, there have been any number of experiments now that have been looking for them, including the LHC, and they just can't find them. Can't find evidence for them. And so people are beginning to look at other alternatives. And one of the interesting alternatives, which I particularly appeals to me, because I spent more than half of my research career working with neutrinos. These are so-called sterile neutrinos that don't interact with the other matter except gravitationally. And that may in fact be the dark matter, and there's some 20 experiments being planned right now to look for these sterile neutrinos. So that's a fascinating new area. Maybe the WIMPs will still show up. Certainly we haven't given up on them, but it's been a long time since the proposal of dark matter, and we still haven't discovered what it is. But it's material. There's no doubt about it, because don't try to look for some spiritual element here, because it gravitates, and spirits don't gravitate. So anyway, the dark energy is also an enigma. It's actually 3/4 of the energy of the universe. And it has this property of having negative pressure, which means that it's driving the expansion of the universe, the accelerated expansion of the universe. And that the favorite candidate for that is the cosmological constant, which was in Einstein's original equations of gravity. Some people said he introduced it as a fudge factor, but that's incorrect. It's just required by those equations. It's like a constant of integration in mathematics. It's just a constant that has to be there, but you don't always know what the value is. And so that cosmological constant is equivalent to a negative pressure dark energy. And what measurements we do have seem to agree with what is expected for the cosmological constant as the source. But that to another fantastic problem, and that is that when you try to calculate from particle physics what that dark energy should be, you get a number that's only 120 orders of magnitude too big. And so people call this the worst calculation in physics history. Now, I is that the calculation that far off has to be wrong, and it shouldn't be taken seriously. And in my book, The Fallacy of Fine-Tuning, I offer a number of plausible other explanations. None of them are proven. None of them constitute a real theory, mathematical theory, but people are still looking for a way to explain the dark energy without having to introduce these many universes, which are not impossible. I think that's a cop-out to have to say, oh, it's that way because there are 10 to 500 different universes out there, and we just happen to be the one that has a very low dark energy.
You mentioned, I'm sorry, Marty, do you have any questions? Oh, never mind. He's eating at the moment. I'll go ahead.
Sorry, my schedule is such that I have to eat during the show. I apologize for that. I'm muting my mic so you don't have to listen to me chewing. Don't worry about it.
Wonderful. We all thank you for that.
Yes.
You mentioned neutrino particles, and a lot of your work had to do with them. So I wonder, what are your thoughts concerning what were supposed to be faster than light neutrino particles?
Yes, well, no one believed them when it was reported about a year ago now, including the people who made the measurements, but they felt compelled to report what they had, and eventually they found that there was an experimental error. There was a loose wire or something simple like that. But it would have been interesting if they had found faster than light particles, because it has the effect, the result of interchanging cause and effect if there are faster than light objects of any sort. It means that if you were riding on one of these objects and you saw something happen where, say, John Wilkes Booth shot Abraham Lincoln, and then you went on for a while, a little longer, and you would find, you'd make another route, you would see something else, you would see Lincoln shoot John Wilkes Booth. So that's one of the kinds of paradoxes that results if you have faster than light particles. So that was the reason why Einstein incidentally ruled them out. They're not forbidden. Faster than light particles are not forbidden by the theory of relativity. But Einstein said, he introduced another principle called the principle of causality. People now call it the principle of Einstein causality. And that is that it said that no particles can travel faster than the speed of light. But that was an additional hypothesis. There was a hypothesis that cause must always precede effect. And in fact, that's simply not the case. There's no reason why cause and effect can't be exchanged, because, as I said earlier, time is reversible. So if you reverse time, what is previously a cause becomes an effect, and what's previously an effect becomes a cause. And so there's really nothing in physics that prevents this exchange of cause and effect.
We have another question from the chat room. What's his name? Caro I can't pronounce that. I'm sorry. He asks, what is with these other quarks in quotation marks? Are there any news on the functions of the different kinds of quarks?
Well, we know of 6 quarks and their antiquarks. The up and down quark form the proton and neutron, and then there's 2 higher generations of quarks, the strange quarks, charm quark, top quark, and bottom quark, and all of these participate in building up the particles that we see in the universe and in particle accelerators. It's just that they are more massive, and so the particles that they make are very massive, and as a result, they're unstable, and they don't last very long, because the protons are very stable, electrons are stable, and they produce the stable part of the universe that we see. But in very high energy collisions, including cosmic ray collisions or accelerator collisions, you produce these other particles. In fact, that's how the whole business got started. Back in the 1960s, when I was a graduate student, we were just first observing all these new particles at accelerators, and it was in trying to explain them in terms of some model that the quark model was developed in the first place, which developed into the standard model of particles and fields. So they form an important part of the universe. Without them, the universe wouldn't be the way it is.
I don't think there are any other questions in the chat room right now, so if anybody doesn't have any other questions, I have quite a few more on my list here.
You go ahead, Lundy.
All right. So one of the other things that I was asked to get your opinion on was potential states of matter in ultra-high temperatures and densities beyond the traditional 5 states.
Well, people are doing these experiments at Brookhaven National Lab in Long Island. They have this RIC accelerator that collides gold with gold and so on, and then the Large Hadron Collider is going to have these heavy ion collisions, they call them. And these produce extremely dense energies. And so there's talk about different kinds of new states of matter being produced, quark-gluon plasmas, and so on. There's some interesting results coming out, but I don't think they've got it all together yet in terms of a new theory.
For the sake of clarity, because I know I'm not, and I think probably about half of our chat room aren't very literate in physics. Could you explain what the states are? And I think I said 5 states. I think it's supposed to be 4 states.
Well, I think you're thinking of solid, liquid, gas, and then if you keep heating up a gas, you'll eventually separate the electrons from the atoms, and you'll have charged particles, and those charged particles are what is called a plasma. The ionosphere, for example, is a plasma because the electrons are stripped from the atoms by ultraviolet light from the sun. And so then what they're saying, so there's 4, and what you're talking about, yes, is a 5th, this quark-gluon plasma, where you're not only split in a regular plasma we're talking about like the ionosphere, you pull the electrons away from the atom. In the quark-gluon plasma, you're basically trying to pull the quarks apart. And the gluons are the photons of the strong interaction that holds quarks together into a nucleus. So by pulling them apart, you're producing this state of supposedly free quarks and gluons. And that requires a new theory, because the current theory, as part of the standard model, so-called quantum chromodynamics, does not allow you to separate quarks from one another. It says that the more you separate them, the more you basically ionize the vacuum. Anyway, it's a long story. Essentially, to make that long story short, it's another state that people speculate about, and they're trying to use.
Caro wants us to state for the record that he is not a quark fetishist, but he has another question about quarks. Yeah, he's asking what news is there currently about quark stars?
Well, I don't know of any new news. I think I would hear about it because I do follow the kind of science news that you get on the internet, and also in some science magazines like New Scientist and so on. And the CERN Courier is actually a very nice magazine for new scientific developments. But at the same time, don't forget, I'm no longer an active researcher, so and I don't get to go to meetings anymore with these ideas are presented. So I can't tell you until it becomes so well known to reach into the more public media. I don't really find out about it unless somebody writes to me about it.
Of course. So another thing that I was asked to get your opinion on, let's see if I can pull up my questions here, was as far as neutrinos go, what is your position concerning neutrinos having mass? Do they have it, or don't they?
I'm glad you mentioned that, because I was involved in the experiment in 1998 that showed that neutrinos had mass. Experiment in Japan, Super Kamiokanda, that won the Nobel Prize for the director of that experiment in 2002. No doubt neutrinos have mass. I mean, that's
been settled then.
Any number of other experiments.
And you can say firsthand, like, yes, that was settled, and I was a part of that. So I think that's a pretty proud thing to say, actually. Like, yes, we have solved that question.
Before retiring, and I have to say though that I was not a major collaborator. I was just working as another hand down in the mine. I enjoyed it. It was fun.
This question was asked in part, I think, because Peter Higgs was not a huge fan of neutrinos having mass. He didn't give them mass himself. So is there any sort of like conflict between the Higgs model and neutrinos having mass?
No, not that I know of. I think what people misunderstand about this is that as long as we had no evidence for neutrino mass, we simply assumed that the neutrinos had mass, and that was part of the standard model that existed up until 1998. But the discovery, some people said, the discovery of neutrino mass violated the standard model. It only violated the standard model where the masses were set equal to zero. There was nothing in the standard model that forbade the neutrino from having mass, and all it did was gave us three more parameters that we had to add, namely the masses of these three neutrinos.
One of the things that's common in social media is movies and these things that the general public tend to see. It's not uncommon for them to espouse very wrong science. I think recently, what was that one movie? Does anybody know? I forget. Prometheus. Prometheus was a movie that was criticized heavily for having highly incorrect science. What have you seen any movies?
So did Star Trek. So did Star Wars.
Star Trek and Star Wars.
Everybody knows they're just fantasies.
True. Do you have any sort of like? Would you recommend that when someone makes a movie like this, they get like a physicist to explain these concepts to them to help them along to make it a little more accurate?
I think a lot of them do, but they would be pretty boring movies if they stuck to the physics.
I suppose so. I mean, it'd be pretty hard to get some of the spaceships and stuff to work as they do if they were going with modern physics.
You notice how every time there's an explosion in space, it makes noise?
Like, that's not supposed to happen. Well, you know, it's cooler when it does, so we're going to have that happen. Well, I guess some things you just can't avoid, at least in movies and TV shows and stuff, because you know they're just trying to appeal to the public, and that doesn't necessarily mean being scientifically accurate.
One of the things that always bothered me about science fiction for years now is the assumption of ESP, or extrasensory perception, the way Spock can read your mind and so on, and that was taken to that was a part of so much science fiction since maybe the 30s. It just was built into it as if it was some kind of reality, some kind of proven scientific reality, and I think it encouraged a lot of people to think that, hey, we really can talk to other minds and move stuff with our minds and so on. And I thought that was a very negative thing to happen to the public comprehension of science.
And I think that's the main problem, because the public sees these things and they think that like, they understand that what's going on in the movie or the TV show, that's not real, but they think that they're being relatively scientifically accurate even when they're totally not, and that's kind of screwing with public perception of science. So I don't know. I go ahead.
One of the I think tremendous negative impacts of all of that was how much money we have wasted over the last 20, 30 years on human space flight. A total waste of time, because we've learned almost nothing from it. All those space labs and so on have produced virtually no useful science at so much greater cost than the robots, and the robots have done such beautiful work. I mean, the Hubble Space Telescope, the Colby and the Wilkinson microwave telescopes, all those probes of the planets, the wonderful vehicle on Mars now, all that stuff. We could have gone so much further if we had taken that money that was going into manned spaceflight and we had just spent it on the robots. And that, to me, that's just a consequence, again, of the misunderstanding of science. And of course, the politicians all feed that. They say, "Oh, we have to move forward. We have to." They imagine some kind of a situation as happened with Columbus. You know, we're going to discover new worlds and we're going to settle new worlds. Well, that's just not going to happen. That's a total pipe dream.
Yeah, I do think that it's very politically motivated to do a lot of that stuff. Just to feel that we've actually accomplished something further than what the general public thinks counts as an accomplishment. Like putting a man on the moon. Oh yeah, that's way more of an accomplishment than the Mars rover. Like no, because it's going to do a lot more when we have the Mars rover.
The man on the moon was a political thing. We had to, after Sputnik, the U.S. had to beat the Russians to the moon, and it was kind of fun. I mean, I think it was a reasonable to think that we were able to go to the moon with the level of technology we had back then. That was quite an accomplishment, and I still kind of enjoyed that. But that was good enough. Going past that to Mars or Jupiter or any place like that is out of the question as far as I'm concerned, especially since the cosmic radiation that the astronauts would experience would probably kill them anyway.
Yet another thing that I was asked to get your opinion on. Well, not by someone else that was outside of this, but Mortimer and we discussed this before we started going live. We have a video that we're going over. It's like a 34-minute video talking about the history of the Big Bang and how that came into mainstream science. And one of the weird things about the video was that it was structuring it in a way to say that the Big Bang is this awful thing for atheists. Like if the Big Bang is true, then atheists are screwed. And as a result, throughout the history of Big Bang's formulation, atheists have been trying to find so many different ways of getting around it. But for me, it's like, I'm fairly certain that the vast majority of, if not all, of physicists and cosmologists today accept the Big Bang Theory as it is. And yet the vast majority of them are atheists. So, and I think this feeds into the whole, cosmological argument kind of thing for God's existence. I know you've debated William Lane Craig. Could you expound on your position as to how the Big Bang really in no way implies that God did anything?
Yeah, sure. First of all, I've written a lot about this in books going back to 1988, how we can understand the universe naturally. But basically, Craig uses the cosmological argument, or the Kalam cosmological argument that you mentioned earlier, basically that everything that begins has a cause, the universe had a beginning, so therefore the universe had a cause. And even if that were true, it's a big jump from that to a personal God of Christianity, which he tries to make it into. And so I debated him twice. First time back in 2003, again a few years ago in Oregon. I noticed he didn't use that argument at all against me in Oregon, which was too bad because I had prepared to answer it again. And I think he knew how I would respond, because he can't challenge it. And that is that, first of all, everything have a cause. We have quantum phenomena that are uncaused already in the universe. Our universe began as a quantum event. About that, we can extrapolate back pretty well to show that. And then, did our universe have a beginning? Well, yes, our universe did begin with the Big Bang. Nobody in cosmology knows the Big Bang itself anymore. But that doesn't mean that it didn't come from an earlier universe. In fact, there's in my book, The Cosmological, the Comprehensible Cosmos, I worked out the mathematical demonstration that of what's called quantum tunneling, how our universe could have arisen from an earlier universe. Now, I didn't invent that. It's found in the literature. I just presented it in a mathematically simple way as I could. And so our universe could have come from an earlier universe. Could be any other universes out there. We have, you see, which is more plausible. Now, he'll stand up there and he'll say, how could it possibly be natural? And all the audience, at least the Christians in the audience, will nod their heads up and down and saying, oh yeah, how could it be natural? Must be supernatural. And that's an argument where I can't understand how it could have happened naturally, therefore it had to be supernatural. And there are a number of scenarios that have been published in reputable journals by reputable physicists providing ways in which the universe could have happened, our universe could have come about without any supernatural intervention required. And that's, as long as there's a plausible natural explanation, then you're violating Occam's razor to say it has to be supernatural. He can't prove that. Nobody can prove that.
Yeah, Occam's razor is a fantastic tool. Zulu, you had a related question, you said?
Yeah, it was more just, what was your overall experience of debating William Lane Craig? I mean,
Well, it's tough to debate because he's he's done it 1,000 times.
Yeah.
And he has this very well developed ability to just carry on very naturally. No hemming and hawing, no with him. And so he's a tough debater. At the same time, he's also, I think, often misrepresents the arguments. For example, I've caught both him and Dinesh D'Souza, who's also another wonderful debater. I told Dinesh D'Souza when he wanted to debate me, I said no, because you'll kill me. However, I said I would be happy to have a collegial discussion with him. We sit at a table with a moderator in between, and we just talk back and forth. But he refused to do that. He liked the format that he was good at. And the same thing with Craig. I tried to debate Craig that way too, and no, he didn't want it, because this time debate where you have a give and take, where you have a preliminary statement and then you have to respond and so on. That takes experienced debater. He probably was a debate captain of college, I imagine, and that's what you learn how to do. I had a debate coach tried to help me on the first debate, but just didn't have that kind of ability. Nevertheless, I'm happy with the job I did. I've had half people review that 2003 debate and who I think I won it, and the other half think he won it. So I think that's pretty good record for who I'm dealing with, and his somewhat misrepresentation of the facts. He's kind of like George Romney, you might say. I mean, not George's son. Mitt.
Yeah, George wasn't actually that bad. I mean, from what I recall, he was an atheist. So,
there is this technique. I think it was I forget the name for it now, but where you absolutely overwhelm your opponent with facts, one fact after another. It doesn't have to be true.
Yeah.
Just one evidence after another, and you just blow the other guy away because you can't keep up with it all.
Yeah. The Gish Gallop, it's called.
Yeah, that's what it's called, the Gish Gallop, because I think Dwayne.
Gish
yes, because Dwayne Gish coined that technique when he was debating creationism. There's actually as far as D'Souza goes, tomorrow night, about 7 p.m., what is it, Eastern Standard Time, I think?
PST, I think it was.
PST, 7 p.m. PST, he's going to be debating Michael Shermer live. I'm not sure where you can get a link to the live stream, but I'm sure if you looked around on Google, you could probably find that pretty easily. It's weird.
I saw D'Souza debate Christopher Hitchens, the late beloved Christopher Hitchens, who was a good friend of mine, as he was a good friend of many people. And in Colorado a couple of years ago, and it was really kind of unfair the way D'Souza was given. It was organized by the Thomas Aquinas Society on campus. I had a moderator who was a local talk show host, right-wing Catholic talk show host, and they had it moderated, and it was really pretty bad. Now Michael Shermer is good, but he's going to have a hard time with D'Souza, at least in terms of kind of audience that D'Souza talks to.
This is the weird thing that I've noticed is, and I noticed this mainly during the D'Souza-Dennett debate. D'Souza, I don't consider him a very strong debater, and this might just be from my perspective, because I don't see him. What I see him do is he says very blatantly incorrect things.
Yeah,
a lot.
Well, that's
well, yeah, but as far as William Lane Craig goes, when he says blatantly incorrect things, you have to have a certain amount of education as far as philosophy goes, or at least be experienced with these topics to be able to point out the flaws. With D'Souza, you really only need like a cursory understanding of the history for most of what he says. So, And when he is in a corner, he starts to raise his voice a lot when he debates. He starts shouting into the microphone, and he sort of gets this like Baptist preacher kind of mentality going on, where he just shouts to everybody and preaches platitudes to everybody. It seems to me that he always tries to divert people from a point if he's ever caught on it, and it seems to me so blatant that I can't consider him a very good debater, to be honest.
Yeah, I don't think he defeated Hitchens. Certainly my view of the debate was that Hitchens easily won it, but it's the whole debate business is questionable procedure. I don't think it's a very good source of information about anything. It's just a gotcha thing, a gimme thing, and whether it's the presidential debates or whether it's these scientific creationism debates, they all amount to very little in the passage of useful information.
Yeah, it's more about the theater of the whole thing. It's always about who presents themselves better that is actually considered the quote-unquote winner, as if it's an objective thing about who won a debate. It's really not, because it is simply a matter of presentation. It's not about who's right, which is what it should be about, but it never is.
Well, so, that both of them continually use, and that's the argument, this cosmological argument concerning the singularity existing at the beginning of our universe, and so therefore time had to begin there. There couldn't have been a preceding time. It's an argument that goes back to 1970 to a paper by Roger Penrose and Stephen Hawking. And it basically was a proof from general relativity, Einstein's theory of general relativity, that the universe had to begin in this singularity. A singularity is a point of infinite density in infinitesimal size. And so they have used that time and time again. And they quote Stephen Hawking in his 1988 bestseller, Brief History of Time, as pointing this out, and it's completely dishonest, because what they do is they ignore the fact that in that very same book, 7 pages later, Hawking talks about how he and Penrose came up with this proof based on general relativity, but it did not take into account quantum mechanics. And when you took into account quantum mechanics, there was no singularity. And Hawking kind of laughs about it. He says, there I was, I got famous for showing that the universe had to begin in a singularity, and now I'm trying to argue that it didn't. And that was in 1988, and Penrose incidentally did not disagree with that. So all the way back, that many years ago, 30 years ago, we have this, the people who prove that theorem saying, well, yeah, but you have to take into account quantum mechanics, and still they use that. I continually hear people use it. Every time I hear any kind of debate involving theists, they pull that, they use that, because they read the same thing. They read William Lane Craig, basically. I think D'Souza also reads William Lane Craig. He doesn't know any physics, he doesn't know any cosmology, whereas I have to admit that William Lane Craig does know physics and does know a lot of cosmology. He just distorts it to apologize for the Christian religion.
See, it's funny. You say that he clearly has a lot of knowledge about cosmology, and that he distorts it. So, do you think that with his level of intelligence and education, he's almost necessarily lying when he uses arguments to the effect that he does?
I find it hard. I think these people somehow talk themselves into it. In their own minds, they're able to find some reconciliation of the ideas, because certainly all these things are arguable. I mean, you can always find something that you can hang your hat on as an excuse. And so, as things get more and more complicated, in other words, For example, the last time I debated him, I said that the universe could have had a preceding universe. He said, "Well, what about this paper?" And he quoted me a paper that I was only slightly aware of, and I had to go back and look up the paper. And he said that these guys had proven that that if you had an inflationary universe, that it couldn't have had a beginning. So he was using that, and it turns out I followed up on that after the debate. I talked to the guys who wrote the paper. I wrote to them. I sent them email messages, and I got responses, which I've put in my book, Fallacy of Fine-Tuning, and they don't agree with him by any means. So he just again misrepresented their paper. People said it in the audience. Wonderful.
William Lane Craig, and here's the thing. There are far better Christian philosophers out there that try and make their case for God's existence than William Lane Craig. But he is the one that's most accessible. He's written popular books, he does a lot of public debates, and so he's listened to far more than the likes of someone like Alvin Plantinga, who, while I still disagree with them, he presents more interesting arguments that can actually be that do require a sufficient amount of intelligence and education, or at least familiarity with the subject in order to debate. But with Craig, I mean, for decades, he's been giving the same arguments over and over and over again. Right. And it's just...
Yeah, you have to realize that, first of all, he's not a Christian theologian in the sense that Plantinga and so on are. He's an evangelical professor and also preacher. He'll always end up making a little sermon at the end that turns his audience of Christians on. And I think that, and he pulls this stuff like his argument about the empty tomb, which he uses all the time, and he'll just swear up and down that there's evidence of this empty tomb where Jesus was buried. I mean, I don't know how he can say that. I mean, we know practically nothing independent of what's written in the scriptures about the crucifixion and the resurrection. Yet he insists that all these expert scholars, New Testament scholars, agree with him that that evidence of the empty tomb is so solid. And in the last debate, I said, well, I have before me a list of 30 people, 30 New Testament scholars, published New Testament scholars, who say that the empty tomb provides no evidence for Jesus. And,
well, yeah, that's...
And he said, I know these 30 people. I've worked with these 30 people. Believe me. They all believe I'm doing. So what can I do? I'm not a New Testament scholar myself. I shouldn't even bring it up, because then he can always just assert his authority over me. I can assert my authority on particle physics and cosmology maybe, but he can assert his authority on that. And so he brings up this evangelical Christian kind of argument that you won't find from the more reputable theologians.
It's such a weird thing for me, because there are levels of apologetics that you'll see in Christianity. There's the bargain bin level of apologetics that you get from the fundamentalists like Ray Comfort or Eric Hovind or any of those people, who are essentially wrong in just about everything that they say, and it's extremely easy to just wipe them off and go, yeah, I've heard that a million times, you're not presenting anything new. It's all wrong. I can just dismiss them almost out of hand.
It's good comedy, though.
It is good comedy. And then you have the next level, which I consider to be sort of like an intermediary level, an intermediary species of apologists, which I would consider the not only William Lane Craig, but all the people who espouse to be like him in their apologetics. And that what I would consider just above the level of people like Ray Comfort, because they sort of mix their arguments between some arguments that are classically interesting, and then other arguments that are just kind of weird, like the empty tomb argument. Because I don't consider, even if that argument were true, even if a tomb were empty, it would not prove anything as to the divinity of Jesus or anything like that. So that's just a weird argument.
It's stolen.
Yeah, there's a lot of alternate explanations you could give as to an empty tomb, even if it were true. So I wish that people would kind of advance past that level, but unfortunately that's the vast majority of people you'll find arguing in favor of Christianity. They're on one of those two levels, and it's extremely annoying because they're very repetitive.
Hello, you still there?
Yep.
Yeah.
But you have a third level to talk about.
The third level. The third level are the people who I would consider to be Christian philosophers or scientists that I actually consider to be fairly interesting to listen to. I've already mentioned Alvin Plantinga. There's also Basil Mitchell, John Lucas, Michael Foster. Interesting people to listen to as far as their arguments go. Sometimes they come up with brand new arguments, like Plantinga's naturalistic evolutionary argument against naturalism. It's an interesting argument, and it takes a little more than your usual talking points that you'll see in just about every debate in order to address. And it takes something that I think is really interesting, like if evolution is true, you probably shouldn't be a naturalist. And the argument essentially goes, we haven't evolved to believe true things, so to essentially go with what our intuitions are saying, and to rely on empirical data and us understanding the empirical data. We haven't evolved necessarily to be able to understand that stuff, so to trust it is unreliable. And you can argue that, but it's different. It's something that's far more interesting than, the universe began to exist, therefore God exists because he had to have made it. It's way more in depth. And I prefer that kind of an argument than the William Lane Craig nonsense.
Sure, I see what you're saying. And in my book, Quantum Gods, I talk about these various theologians who are trying to come up with a model of God that's consistent with science. They respect science. They said, let's make sure that we don't disagree with science in any way. Let's take into account quantum mechanics and chaos theory and so on. And so they develop this model of God. You also see the same thing in the books by Francis Collins and by Kenneth Miller, both very well-known and accomplished biologists who believe in evolution, but at the same time are very devout Christians. They come up with their own kind of model of God. And while these models are consistent with science, they're not consistent with Christianity, is the point that I make in the book. They're basically deist gods, gods that set up the universe to begin with, a God that set up the universe to begin with, and basically, as I call it, through the dice, because there's so much randomness in the universe, and randomness plays such a role in the development of the universe, not just biological life, but in the evolution of stars and everything else. That any God who created the universe would have had to use randomness as part of that process, and these people are aware of that, and so they're trying to accommodate that by imagining a God that uses randomness to create what he intends. And I say that's perfectly plausible. It's not. There's no reason to believe in such a God. No evidence for such a God. But that's a God that you can't rule out of hand. The trouble is, it's not the Christian God, because the Christian God is a God that, and the Abrahamic God in general, is a God that not only created the universe, which you can't demonstrate there was a creation, it also is a God that performs miracles, but no miracle has ever been demonstrated, and plays a role in human life, answers prayers. Well, where has there ever been a prayer demonstrated of the billions and billions of prayers that have been sent over the ages? Where has anyone ever been demonstrated to come true? A God who talks to people, who presents them with knowledge about reality that they couldn't possibly have known prior to their religious experience, let's say that near-death experience or whatever it is that they went under. They come back, because that's a testable thing. They can come back with some information if they really did spend some time in another dimension. If they could come back with some information that they could possibly have known, that could be then tested scientifically, but that's never been done. So that's the problem with this whole Christian apologetics position. On the one hand, they have no evidence to demonstrate that their God exists. On the second hand, there's lots of evidence that he doesn't. And that's it's been my theme from the time I wrote my 2007 book, God, the Failed Hypothesis. I've tried to demonstrate that it's not just a question of absence of evidence, not proving evidence of absence. Absence of evidence can prove evidence of absence if it's evidence that should be there, and it's not. And these are all cases I've given, I discuss in the book, of cases of if there exists that type of God in the universe, there should have been by now scientific evidence for that, evidence that could be observed and checked and verified. I give examples. One example I'd like to give is that suppose that it's shown by very carefully done experiments that only prayers by the Pope heal the sick. Nobody else's prayers. No other Catholic prayers work. No Muslim prayers. No Jewish prayers. Hindu prayers. None of them work. Only the Pope's prayers work. Well, I don't know how you'd explain that. Naturally, you have to say, well, maybe there's something to it after all. And so this is all within the realm of scientific possibility to prove that this type of God, a God that participates in the universe, exists. But that hasn't happened. And whereas these guys are proposing a God that really doesn't participate in the universe, so that's not the Christian God.
From what I know about Kenneth Miller, go ahead, Kitch. I've been talking forever.
That's grand. I actually want to ask, now that I think of it, you have, I've seen you talked about alternative medicine, and one of the, something I talked about myself before, and something that you've mentioned in one of your articles is the energy field. That's something I haven't come across. Could you explain what the hypothesis behind that is, or what exactly that entails?
Yeah, if you look at some of the literature on alternative medicine, you'll find very often the use of energy. Energy appears all the time in the literature, whether it's Chinese medicine, acupuncture, or there's another area was very popular at least a while ago. I haven't followed up and seen much of it lately, but something called therapeutic touch that was actually being taught in nursing colleges across the country, where a nurse would move her hands over a patient and manipulate the bioenergetic field that the patient was supposedly emitting. So there was that whole theory about this notion that there is some special living force that is associated sometimes with the electromagnetic field, but they also call it quantum. They really don't know the physics. In other words, they just use these words because they sound scientific. And
magical science.
right.
Got
the life force thing. Was it therapeutic touch, or was it some other similar thing that was disproved by a 9-year-old?
11. She was 11.
Oh yeah, 11. Yeah, whatever. It was disproved by a kid anyway.
Therapeutic touch.
Yeah.
Right.
Did I hear you right? That you said that was taught in.
She happened to live not too far from me, and I've met her a few times. Just a wonderful, beautiful girl. She's of course in her 20s now, I believe.
Yeah.
Did I hear you right to say that the therapeutic touch was taught in nursing school throughout the country?
Oh yeah, it was very common. Very common. There's a whole book on therapeutic touch from Prometheus Books. I have a chapter in it. You know, if you go to my website, you will see I have a page on alternative medicine that contains some links to some articles I've written on bioenergetic field. So there's a lot of material on all these things that you're raising. If you want to follow up on them, a good place to go is to my website to get started. Lots of references to other papers and books, not just my own, and you could follow up on these stories.
And I've also seen that you've talked about homeopathy. Why do you think that this idea of homeopathy seems to get so much traction throughout the populace, especially in the likes of the NHS in England? As far as I'm aware, that actually is that has got funding. Am I right? I'm not the right person to talk about the NHS.
Yeah, it has got funding, and it was a few. I don't know if you saw Richard Dawkins when he did that documentary, Enemies of Reason, and it was like saying £20 million had been spent on building a homeopathy clinic. You know, with taxpayer money.
It's really terrible.
Yeah.
Because it can't be right. I mean, that's, see, these are the things where a little bit of physics helps. I can give you other examples, like worry about radiation from cell phones or power lines. A little bit of physics, simple, fresh, high school physics is all you need to show why that's impossible. I mean, the way homeopathy works is there can't be a single atom, after they do all that dilution, there can't be a single atom of the so-called, whatever the substance is that is supposed to be doing the work. It's been diluted in water at such a level that it would violate the atomic theory of matter, let's say, if homeopathy were to be shown to work. Now, of course, we take the experimentalist's view, find evidence for it, and then when you have the evidence that shows a theory is wrong, then the theory is wrong. Find the evidence, and I should have made this clearer. One of the points that I always try to make very early on in these kinds of discussions is that as a scientist, any scientist has to go where the data are. The data say that this theory is wrong, then the theory is wrong, and you move on from there. And so if they ever found any evidence that it really worked, then we would have a real problem. But there is no evidence. There's not a single convincing experiment at the kind of statistical level that would be convincing. A lot of stuff gets published in these journals that are on the fringe, or in pseudoscience rather than science. That make such claims, but nobody ever is able to demonstrate it. And for me, the way science works is it's not just a matter of demonstrating it to each other. I had this argument the other day in another interview about the evidence for near-death experiences, and this guy who's supposed to be a skeptic, my moderator, kept saying, well, why don't you believe what the experts say? They say they can't understand how that can happen, blah, blah, blah. And I said, yeah, that's the argument from ignorance again. Just because they can't explain it, even if they're experts, that doesn't mean that we won't find an explanation someday. And they're not, just themselves is not going to sell. They have to convince skeptics. Once the skeptics believe, once the scientific community as a whole believes, then they'll have their ideas will be part of scientific knowledge. But until that happens, they're going to just be waving their arms around until they find some evidence. So that's the ultimate requirement. And so with homeopathy, find the evidence. With any of these other claims, find the evidence. There's no evidence that acupuncture works. I tried it for a couple of years. But for a while there, I thought it worked, but it just placebo. At least as far as I was concerned. That's what the experiment indicate. Chiropractic is another thing that spend a lot of money on and just swear by it, and yet it's quackery. So alternative medicine is an unfortunate thing, and it kind of comes from not understanding the science. I mean, things like power radiation. When I was living back in Honolulu, I participated in a panel by the city council that was discussing. It was a TV panel that the city council had of Honolulu had radiation from power lines. And there was this old gentleman came in holding his grandson, and he said he just didn't want his grandson exposed to this radiation. And of course, I tried to explain to him that, look, the energy in the photons, if you take that child out into the sun, he's getting more ionizing radiation from the sun just walking along there without a hat on his head than he would be getting walking under a power line or living under a power line, because you just have to calculate the amount of energy of a photon from the sun, the amount of energy of the photon from an electromagnetic radiation from a power line. You know what the difference is? About a factor of 1 trillion. That photon from the sun is 1 trillion times more energetic than the photon from the power line. And so, simple physics, you can understand these things, and the sad part about it is that the general public has practically no knowledge of physics. And incidentally, it's their fault. It's a lot of fault could fall upon physicists for not doing a better job of teaching.
Yeah. Oh, sorry.
If it's okay, I had a couple more questions before we close out here in about 10 minutes.
I just have one more question, Lundy.
Go for it.
If that's grand. I just want to comment on why some of these ideas have gotten so popular. Is that if you go onto the websites of some of these websites, like the homeopathy or stuff like that, they look very professional, and someone who doesn't have a background in science might get fooled by them. Another thing that I've also discovered is that on the Web of Knowledge, it's a quite popular science database of different journals, is that they have homeopathy listed as one of their journals, which is quite astonishing to me. Just wanted to get your opinion on that. The database is the Web of Science.
Well, I obviously don't approve of it. I don't know what else to say. I think that it's too bad that these things masquerade under the title of science. And incidentally, I'm very critical of scientists in general, because I think they are too willing to go along with magical thinking, whether it's in religion or in pseudoscience. And this is magical thinking when you imagine these spiritual fields emanating from your body and so on. Or that homeopathy works because it tunes into the cosmic consciousness that we're all part of. That's all a huge misuse of science. And the people who promote it are misusing science, and the scientists let them get away with it. And I am highly critical of scientists for doing that. They do it because they don't want to make the population mad at them. They need the support for their research. And I've written any number of things. In fact, if you look at the latest Huffington Post, that's just came out yesterday, I wrote an article on is evolution consistent with religion, and I argue that it's not, and the scientists know that, but yet they won't admit it. They won't say it publicly because they don't want to get on bad terms with religion. The reason, incidentally, is because if you look at the surveys, I present a survey, a Gallup survey of people, Americans' belief on evolution, and while only actually 16% of them believe in evolution, in which God plays no role. The rest of them either don't believe in evolution at all, 40% don't believe in evolution at all, and another 30% believe in what's called theistic evolution, where, oh yeah, we evolved from other forms of life, but it was all guided by God. Well, that's not Darwinian evolution. And scientists know that, but they sweep that under the rug. And here again, with these other cases, they're just not standing up for good science, and it's bad. They have a short-term interest, of course, in keeping the public happy. In the long term, they're encouraging magical thinking, and the magical thinking leads to all this misunderstanding about things like global warming, things like birth control, and so on. That's very dangerous to our survival on this planet. If we don't take a scientific grip on these things, this planet's in trouble. We all know that, and yet nobody does anything about it, and especially scientists aren't doing enough about it.
We only have time for one fairly quick question. So I'm going to go with the chat room question here by the Real MG. He says, "What is the craziest assertion you've ever heard?"
Oh,
I know it's hard to just pick one.
God exists.
So the craziest assertion is that God exists, then.
The idea that this vast universe, with here we have 100 billion galaxies, each with 100 billion stars, maybe a trillion planets, and that's all just our visible universe that we can see with a telescope. Beyond our light horizon is probably a universe that's 10 to the 100 times bigger, that all came from the same Big Bang, and then there may be many other universes, and then a limited number of other universes out there. And to think that there's some supreme being out there ruling over all of that, still looks at we puny humans on this tiny little planet as so important that he's created the whole thing just for us, so that we could live eternity with him and provide him with company. That has to be the craziest idea I've ever heard in my life.
If not the craziest, then possibly one of the most arrogant. The creator of all of this loves you in particular. So we have about 5 minutes left. I don't think we really have any more time for a big question. But in the 5 minutes, I'll go ahead and let Zulu begin closing us out.
Yeah, I think we can just fit this one. It's for Dr. Stenger. I hear you've got a new book coming in 2013, so if you can give us a quick rundown of what that's about.
Yes, that's called God in the Atom. And it doesn't have a subtitle, but it has some kind of a reference on the cover. to something like from Democritus to the Higgs boson, the story of triumphant idea, and it goes back to Democritus, works through the ancient atomists' view of the universe as being made of just elementary particles and nothing else, that there are no gods, or if the gods that exist don't really care if they do exist, don't really care about humans. Why should they? Why should they be bothered with humans? They have perfect lives of their own. And so it goes through the history of atomism, through the Dark Ages when it was suppressed, and how it came back, was rediscovered during the Renaissance, and then became the foundation of the new science that developed, Newtonian mechanics, very much based on particle mechanics. And I carried that right on up to the discovery of the Higgs boson. In fact, I held off. I had the book, most of the book written for a while, and I held off sending it in until I finally had the word on the Higgs boson in July, and that enabled me to finish it off with a nice discussion of that. So this is coming out from Prometheus Books. They plan to promote it as their #1 book next year for the spring and the winter and spring season. I'm not quite sure exactly when it'll come out.
Okay, that's great. I think we'll wrap up there. So thank you very, very much, Dr. Stenger, for coming along. It's been fantastic.
Well, I sure have had a good time talking to you. The questions have been excellent, so it helps me to have to answer those questions. It gets me thinking too.
All right. And thank you to all my co-hosts again. We are back in 13 days, it is. We have Dr. Massimo Pigliucci joining us in advance of him releasing his new book. And then the very next day, we have Graydon Square in our show. So that's 20th and 21st of October, a double header for us. So everyone, please tune in for that. And thank everyone for coming along. The show will be uploaded imminently on YouTube. So again, a big thank you to everyone, and we'll see you in 2 weeks.
Also, I just want to announce that I will be doing a live show this Thursday on the topic of science and the public from Berlin. Attending a conference in Berlin. I'm arriving a day early, so I just thought I should do a show while I'm over there.
Are you going to use is that going to be broadcast on Tool or your own channel?
Rolling with Logic, I think
okay.
Would probably be the best place.
All right, so...
And, at the time will be decided then, because I'm not too sure on time difference and whatnot.
Okay, so good night everyone. Head over to Graydon Square's blog TV. He's just started up right now. He's a very cool friend of ours. So thank you everyone, and good night.
Night everybody.
Night everyone.